Today we're going through maximum subarray, and it's an easy question, highly liked. So let's work through this. Given an integer array nums, find the contiguous subarray which has the largest sum and return its sum. Contiguous subarray simply means like indices that are consecutive. So this is a contiguous subarray, this is a contiguous subarray, but 3, 4, and 2 is not a contiguous subarray. Even though it is technically a subarray in ascending order of indices, it's not consecutive indices, okay? This is actually a funny question. I remember I was in college and this question or variation of this question was on the midterm. And I was panicking so much because I had totally forgotten the trick to solving these kinds of questions. And the trick is dynamic programming. And we'll talk about how we use it, but it was just funny. Like I was panicking so hard on the test. I was sweating and my leg was twitching. And so giving me flashbacks here. So for these kinds of questions where I'm not really sure where to start, I always like to think, how would I solve this in real life? So how would we solve this? So you'd say, okay, -2 and 1. That's a subarray of contiguous subarray that sums to 1, to -1. This sums to -4. This sums to 0. So far, this is our best subarray, right? This sums to -1, this sums to 1, this sums to 2, this sums to -3, and this sums to 1. So overall, if we sum everything together, it's 1. Our best so far is 1, and that's how we kind of go about this. However, we see here that the output is 6 for this example, and it's because 4, -1, 2, and 1, this contiguous subarray is the most optimal. So basically what it's saying is by adding in these other numbers, our eventual sum, our sum at the end of the adding, is going to be less than if we excluded these numbers. So the question is, which numbers do we include to have the best sum? And right off the bat, 4 is a good place to start, right? I know this is my highest number. Let's work away from, let's work with this to see what we can get. So I'm not exactly sure how to recognize this question as a dynamic programming question, but I do recognize it as that, and I'll explain to you why, and we can walk through this example. Given this input array, right, we want to kind of mimic the same input array with a bunch of negative infinities all the way across. So I'm just going to write -0, and we want to do that the same amount of times. Oops. The same amount of times as there are elements in the original array. So I think there are 8 here, and there are 8 here, and there are 9 here. Okay, so first thing we know is the best contiguous subsequence starting from this end is going to be 4, right? Because nothing after this you can add to get a higher value, right? Then you go here, you say the best I can get right here is either going to be -5 or the sum of -5 plus the best I had previously, so 4. So in this case, -5 is less than -1, and so this becomes -1, the max of those two values. So here we have another question. So here we have 1. Say 1 is either the max value we can get at this point, and by adding in the rest of these, or it is we add 1 or it's 0, right? Either the max value is 1 or it's 1 plus -1, which happens to be 0. In this case, 1 is greater than 0, so we put 1 here. Now again, we have 2. 2 is high, right, in this example, but 2 plus 1, which is our previous best, is better. So 3 goes here, right? Now -1 is low, but -1 plus 3, which is our previous best, is 2. So 2 goes there. Now 4 is here. 4 is high, but it can be even higher by adding in the following values. So here we have 6. So 4 plus 2 is 6. Okay, then we have 6. -3 is low, plus 6. The best value we can get here is 3. All right, same thing. The best value we can get here is 4. Same thing here. The best value we can get here is 2. Okay, so here we have an array that holds the max sum of contiguous subarrays that begin at this index. Okay, so the value here, the best value we can get for subarrays that begin on this index is 4. The best we can get here is -1, since -5, the two subarrays that exist are -5 and -5, 4. a -5, 4 has a higher sum than just -5 alone. So that's the point. We want to get this array. We want to pick out the max value, and that'll be our answer. So let's try to code this. Yeah. So first things first, if not nums, return 0. Easy. Then we want to initialize our helper dynamic programming array. So let's call it best at index. It'll be an array full of zeros times the length of nums. So it'll be n zeros in this array. And we want to initialize it, the last value, to be the last value of our nums. Okay. And then eventually we want to return the max value within this best at index array. So what we said we wanted to do was work our way backwards through this array. So we need to, let's look at this example. We want to work our way backwards. Our best at index is already done for this one, so we want to start considering this one. So I equals length of nums, which in this case is 9. And we want to consider the 7th index, which is this one. So we do 9 minus 2 is 7. So then we say, while I is greater than -1, our current value is equal to nums of I, so in this case, -5. And we say, okay, our best at index at the 7th index, I in this case, is going to be either the max of our current value, or it's going to be the sum of current value plus our best at index of the previous of the index 1 greater than we're on currently, so I plus 1. Okay, that's what we were doing before when we were comparing. When we had 4 here, we're saying, okay, does the value here become -5, or is it -5 plus 4? And what we're doing is basically choosing the greater of those two values. In this case, it would be this. In other cases, it will be this. And then lastly, once we figured out what our best value could be at that index, for a subarray that begins at that index, we want to decrement I. And then that should be it. Let's run this, see what happens. Cool, so it knows it's 6. We should even print out our best at index just to see how we're working on this. We can do it here too. Okay, now let's change the input a little bit. Let's make it -13 and 12 here. Let's see what happens. Okay, yeah, so it's working its way one by one across this best at index array. And eventually we see that 16 is our highest and 16 is our answer. So this looks good to me. Let's run it on some edge cases. So the empty array. Oh, cool. So this is actually great that we checked this. Let's handle this. And so I actually don't like that this answer is considered wrong. I think if there are no numbers in our subarray, our maximum sum is 0. I like that answer. So I'm just going to submit anyway, and I know this works because I just ran it a few seconds ago, but there we go. We got the answer we were looking for. We did some kind of dynamic programming where we kept our previous computation in an array by saying this is the best sum of a contiguous subarray that starts with this value, starts with this index, and we did it.